We will solve two coordinate geometry questions from Class 9 using the distance formula step by step. First, I will write the distance formula we will use again and again. The distance between 2 points, x1, y1, and x2, y2, equals the square root of the quantity x2 minus x1 squared plus y2 minus y1 squared. Problem 10. Show that the points A of 3, 2, B of 4, 1, C of 5, 4, and D of 6, 3 are the vertices of a rectangle. Our plan will be to show that both pairs of opposite sides are equal, which makes a parallelogram, and then show that the diagonals are equal, which makes a parallelogram into a rectangle. Let's plot the points on a coordinate grid and connect them to visualize. First, compute lengths of the four sides using the distance formula. We will compute AB and CD, then BC and D, just as written in the textbook solution. AB equals the square root of 4 minus 3 squared plus 1 minus 2 squared, which is root 2. CD equals the square root of 6 minus 5 squared plus 3 minus 4 squared, which is also root 2. So A, B equals CD. Next, BC equals the square root of 5 minus 4 squared plus 4 minus 1 squared, which is root 10. DA equals the square root of 3 minus 6 squared plus 2 minus 3 squared, which is also root 10. So BC equals DA. This shows both pairs of opposite sides are equal in length, so the quadrilateral is a parallelogram. Next, we show the diagonals are equal. AC equals the square root of 5 minus 3 squared plus 4 minus 2 squared, which is root 8. BD equals the square root of 6 minus 4 squared plus 3 minus 1 squared, which is also root 8. Since in a parallelogram the diagonals are equal only for a rectangle, we conclude it is a rectangle. Problem 11. Use the distance formula to show that the points O of 0, 0, A of 3, 0, B of 5, 2, and C of 2, 2 form the vertices of a parallelogram. We will check that the opposite sides are equal in length. Let's plot these points and draw the quadrilateral OABC. We will compare the first pair of opposite sides, OA and CB. OA equals the square root of 3 minus 0 squared plus 0 minus 0 squared, which is 3. CB equals the square root of 5 minus 2 squared plus 2 minus 2 squared, which is also 3. So O equals CB. Now compare the second pair of opposite sides, OC and AB. OC equals the square root of 2 minus 0 squared plus 2 minus 0 squared, which is root 8. AB equals the square root of 5 minus 3 squared plus 2 minus 0 squared, which is also root 8. Hence, OC equals AB. Therefore, both pairs of opposite sides are equal, so the quadrilateral is a parallelogram. Summary. In problem 10, opposite sides were equal and diagonals were equal, so the 4 points are vertices of a rectangle. In problem 11, both pairs of opposite sides were equal, so the 4 points are vertices of a parallelogram. Distance formula is a powerful, reliable tool for such proofs in coordinate geometry.